Hello my students, good evening to all of you. So yes, today we will discuss all the important questions that you are going to face in PU1 examination. Jeevan is saying hi ma'am. Sumit Kumar, hi ma'am, very good evening. Okay, Sumit Kumar, today one of my PU1 friend met with an accident and no more alive. It's really very much okay. It's very much disheartening news that we are beginning with, but it's okay, don't worry. Wherever he will be, his soul will be rest in peace. Don't worry, my dear. So do your best. Yes, my dear, my health is somehow going on. Like I got some injuries on my leg itself. So yes, without further delay, let's start it. Here majorly we will discuss on the numerical that I planned actually, because in the PU1 examination I have seen students, they are struggling with the numerical. Yes, MCQ also we will do some fixed question. We will do the problem of this year is we are not getting any fixed blueprint because your college will prepare the question. So at the end of the day, the suggestion that is given by your college itself, that will be your primary target. Okay, but what I will cover here is the overall point of view I will give you. From there you will see that some specific target zone I have selected, because if I just take one chapter, only those questions are possible, only those important zones are only possible. Okay, maybe whatever college you are coming from, those possible question you can face in the examination. So those I just have make a cluster and I'm just trying to produce in front of you. Okay, so yes, without further delay, let's get started. We will go chapter wise. Okay, and definitely we will focus majorly on the numerical based problems. Okay, so here you can see first chapter we will start with, that is some basic concept. As you can see, first a little bit numerical we will, little bit MCQ we will start with, and then we will proceed with some fixed question along with the numerical problems. So in a particular reaction, one of the reactants limit the number of the products formed, that is definitely it is called the limiting product, right? Sorry, limiting reagent, right? So limiting reagent means the reagent that is there in lesser amount, and as a result of this, that will limit the reaction, right? So this is the answer. Let's proceed further. I will move a little bit faster because all the answers will be given here and you will get the entire PDF after the session. Okay, so here you can see this is the empirical formula. The definition of empirical formula is very important, along with the relation of empirical formula and molecular formula. So here molecular formula, the definition is also important, that you can go through once. And here comes a very important question, numerical problem definitely. So this type of problem I will focus, that you actually can face in your examination. Okay, so for this question you can see a compound contains 4.07% hydrogen, 24.47% carbon and 71.65% chlorine. Its molar mass is given. What are the empirical formula and the molecular formula of this? Okay, so first let's make a table so that you can understand this thing. So we will start definitely along with the elements. So here we will write the elements. Here we will write the percentage composition. Here we will write atomic mass. And then we will do percentage composition divided by atomic mass. Next, in the next column we will make it simple ratio. So divide by the smallest value. Divide by smallest value. Okay, and here we will do the round off. Okay, so first here elements are given definitely carbon, hydrogen and chlorine, right? So carbon, here we will do hydrogen, here we will do chlorine. So for carbon, what is the percentage composition? You can see it is given as 24.47. So 24.47. 0.47%, hydrogen is given as 4.07 and chlorine is given as 71.65, right? So now atomic mass of carbon is 12, for hydrogen it is 1, for chlorine it is 35.5. Okay, so percentage composition divided by atomic mass, if I do this thing, then 24.47 divided by 12, and here what I have to do, 4.07 divided by 1, and here 71.67 71.65 divided by 35.5, right? So now if you just do this thing, first case you will get something 2.02, for this case definitely it will be 4.07, sorry, for this case it should be something around of 2.02 only, 2.01 actually. Okay, now this is the smallest value. With the smallest value we will divide all the three things. So 2.02 divided by 2.01, so almost it will give you something 1. Okay, here 4.07 divided by 2.01, right, that will give you something 2.03 nearby, 2.02 actually, and here 2.01 divided by 2.01, that will give you 1. So now we will count the round off value, that is 1, 2, 1. So once you are done up to this step, then you can write down the empirical formula. So empirical formula will be something like, so how many carbon you can see in your system? 1 carbon, right? So carbon, how many hydrogen? You can see 2 hydrogen, and chlorine is 1. So now you have to find out the empirical formula weight, the molecular weight that is coming out of this empirical formula. So 12 plus hydrogen, how many? 2 into 1 plus 35.5. Okay, so if you calculate this, it will come almost something like 49.5. This is your empirical formula weight. So now in order to calculate the n factor, what you have to do, empirical formula weight divided by the, molecular formula weight divided by the empirical formula weight. Molecular formula weight is how much? 98.96 divided by 49.5. If you do it, almost it will come as 2. So from there I can write the molecular formula, empirical formula, whole n, right? So from here I can write CH2Cl, right? From here I can do C2H4Cl2. Okay, so many steps are involved in this case. So please make sure that you're focusing on each and every step, because maybe in the last step you're making some mistakes or something. You should get at least the step mark for this case. Okay, so I guess this thing is clear to you. Okay, so let's proceed. Okay, I can see Sumit Kumar with one doubt, that is, ma'am, I have a doubt, how can we find whether of a compound has both same molecular, okay, whether of a molecule with same molecular and empirical formula. Yes, whenever the n value will come 1, this n factor that I am calculating, if the n value is coming as 1, then you can say that yes, the molecular formula and the empirical formula is same. Just let me give you an example, methane. Okay, so methane is the simplest version. Okay, only 1 carbon is possible, right? So for those particular cases like H2O, CO2, right? For those particular cases, you can tell that yes, my molecular formula and empirical formula is same. Okay, so the main thing is you have to check that if the n factor is coming 1 or not. Okay. Yes, let's proceed further. See, this is the definition of limiting reagent, important. Okay, next question, here you can see this type of problem, this type of numericals are very important. Okay, like I only am targeting the main focused numerical zone from where actually the question comes. Okay, so please practice this type of thing, it will help you to do any type of numerical. Okay, so yeah, let's proceed with the question. Here you can see the density of 3 molar of NaCl is given. Calculate the molality of the solution. See, here is a trick. There is a small trick wala formula that also you can apply directly, but the calculation portion becomes a little bit difficult in those cases. Okay, so better to break it down and proceed further. Okay, molecular weight of NaCl. At first let me find out. Molecular weight of NaCl, it is definitely 35.5 plus, okay, 58.5 gram per mole, right? So now what you have to proceed with, whenever they are saying that I'm having 3 molar solution, so by default they are giving you the information you are having 3 mole present in 1 liter. You have 3 moles of NaCl present in 1 liter. Okay, so from there I can get the mass of NaCl that is present. So mass of NaCl as a solute, NaCl as a solute that is present. So 3 mole, right? So 3 into 1 mole means 58.5 grams. So 3 into 58.5 grams. So if you calculate this, just give me a minute, it will give you something 175.5 gram, right? Okay, so now mass of the solute we found. Now we will get the mass of solution. Mass of solution. Okay, how I should get the mass of solution? See, volume I got how? Because I am telling 3 molar solution means 3 mole present in 1 liter. So volume of the solution is 1 liter. Now density, you know, you can calculate the mass. Mass equals to D equals to M by V. Density equals to mass by volume. So from there mass you can calculate. So mass is definitely is going to be volume into density. So volume is 1 liter, means let me just write 1000 ml into 1.25 is the density, right? So if you calculate 1250 gram, it will come, right? So mass of the solution I know, mass of the solute you know. So now mass of the solvent, because I have to calculate molality, right? In order to calculate the molality, you need the mass of the solvent in the denominator part, right? So let's calculate mass of the solvent. Okay, so mass of the solvent, how you should calculate? Definitely solution minus solute. If you do, you will get the mass of the solvent. Okay, so just let me do that. 1250 minus 175.5. It will give you how much? 0.54701. This gram. Right? I guess it is clear now. Now what I am going to do, I am simply going to put the formula of molality. Everything I am having now. Mass of the solvent I need, I am having it. Mass of the solute I need, I am having that. Molecular weight I know. Fine. So now let's calculate the molality. So molality is basically equals to mass of the solute divided by molecular weight of the solute into weight of the solvent into 1000, right? This is the formula. Let's put it. 175.5 gram is given here into 1000 divided by M2 is 58.5 into 1074, right? 1074.5. Okay, so if you calculate this, you will get the answer something like 2.79 molal. Okay, that is the answer of this question. Or just let me tell you, here comes another formula where you can directly put the value, okay, utilizing the density. So molality is basically equals to capital M divided by capital M is the molarity. Okay, this M is the small m. Wait, let me write it directly. There should not be any confusion. This is molality. Okay, this is molarity divided by, this is rho minus capital M into molecular weight of the solute divided by 1000. Okay, so just proceeding a little bit with this thing, just put the value here. Molarity is given 3, density is given as 1.25 minus molarity again 3 into molecular weight of the solute, that is 58.5 divided by 1000. Okay, so if you calculate this thing also, you will get the answer. So this is another trick. Okay, so any one of the method you can proceed with, but I will always suggest you, whenever it is a board exam, please more the steps you will do, there are more chance that you will get the marks. Okay, so follow the steps wise. Whenever I'm doing more steps, follow that method. Okay, so I guess it's clear. Okay, yes my dear, 3 marks question only you will get out of it. 3 marks question, 4 marks you won't get actually. See, I'm telling you the pattern. Definitely you will start up with the MCQ, fill in the blanks, then 2 marker question, then it comes 3 marker question. Okay, 3 marker question and then 5 marker question. In the 5 marker question, maximum highest point you will get 3 actually. Okay, in 5 marker there comes part marking, 3 plus 2. Okay, 2 plus 2 plus 1, this type of part marking. So maximum highest marks that you have to attempt, it's 3 mark. Okay, so that is the thing. So I guess it's clear. Let's proceed further. Okay, here you can see this is a very important question. Please don't forget to go through this question. Okay, what is the molecular formula, how it is related to the empirical formula? Give an example for a compound whose empirical formula and molecular formulas are same. Always remember, when the value of n, whole n, that value will be 1, that molecular formula and empirical formula will be same. So for this particular question, you can write water, methane, carbon dioxide, so many, sulfur dioxide, so many options are there. Okay, for the first question, you know, I already told you what is the definition of empirical formula and molecular formula. It was already there in previous slides. So basically, molecular formula, the relation that you have to mention here, molecular formula is basically equals to empirical formula whole n. Okay, here please mention what is basically n. N is basically equals to molecular weight of the compound, molecular weight divided by empirical formula mass. Okay, I guess it is clear now to you people. Okay, so yes, let's proceed accordingly. Okay, before proceeding to the next chapter, let me just tell you, my dear, definitely you people have some target in your future. So if the target is to crack KCET examination, then yes, you are in a proper zone. Deeksha Karnataka is a proper channel. Just below my video you will get the link for a free mock test. So if you wish, you can go ahead with the link and you can enter your mobile number, you will get the OTP, you can log in and you will be guided for a free mock test. If you wish, you can attempt it, and I guess it will be helpful for your upcoming KCET preparation as well. Okay, let's proceed. This is the atomic structure chapter that we are going to study. Here we will discuss some important MCQ question at first. So here you can see Bohr's theory is not applicable for. Okay, Bohr's theory is something that is applicable for only hydrogen-like system. Hydrogen-like system means the atoms or the species where I am having only one electron. Okay, so here you can see He plus, Li2 plus, Be3 plus, all are having one electron except this. H plus is a proton, it has no electron at all. Okay, so yeah, I guess it's clear. Let's proceed further. The splitting of spectral line in presence of magnetic field. So this is called Zeeman effect. Okay, sometimes people get messed up if it is a Zeeman effect or Stark effect. Always remember Zeeman, it includes M for magnetic field. Okay, so remember it in this way, and in electric field the splitting of lines are called Stark effect. Okay, so yes, let's proceed. the principal quantum number that signifies, definitely it is the size of the orbit. Okay, so yes, let's proceed further. The incorrect set of quantum number. Okay, so whenever n value something, then L value should be 0 to n minus 1, right? Whatever the n value, minus 1. Okay, so here you can see it is a possible way, 4 minus 3, so 0 to 3, any possible option can be there. Okay, but for this case you can see L value cannot be 4 when n is also 4. It should be within 3, 0 to 3, right? So this is the wrong option. Okay, incorrect set. I guess it's clear now. Let's proceed. Okay, so here comes some question. Please make a note of this question. Expected that from these zones only you will get the questions. So this is the two drawbacks of the Rutherford model. As you know that there is no proper orbit or the path of electron, right? And it also failed to explain the emission spectra and Stark effect, Zeeman effect. Those are also Bohr's thing will come and all. So you can just proceed with this. Let's proceed. This question I have taken from the model paper, though I will further solve the model paper for you in a different video that will come by this week only. So here what is the thing? See, a neutral atom has 2 electrons, 8 electrons and 6 electrons in K, L and M shells respectively. Okay, from these predict its atomic number, total number of S electron, total number of P electron. Okay, so 8 and 6 electron, right? They are saying 8 electrons and 6 electron in K, L and M shell. So 8 and 6, if you add them, it will come up to be 14. So total I am having 14 electrons. So now this 14 electron you fill up in SPDF. Okay, so you can see 1s2, 2s2. So here 4 it comes, 2p6, total 10, 3s2, then 2p4. I guess, sorry, 3p4. I guess 14 is clear. 2 plus 2, 4, 10, 10 plus 2, 12, okay, 3p2, right? So you have to end up with 3p2 system. Okay, so from there atomic number is the, you know, the total number of electron that you can call it as atomic number. Okay, so atomic number is going to be 14. Okay, total number of S electron, count the S electron, this and this, total 6. Right, 6 is the S electron. Total number of P electron, how many? 6 plus 2. 2p6 plus 2. This is 8. 8 is the P electron. I guess it is clear to you? Yes, let's proceed further. Okay, so this is, here comes the definition of photoelectric effect. I guess you already know this. The process of emission of electron when the surface of the metal will be struck by some light or photon. Okay, so now here you can see one problem. So definitely I will focus on the problem majorly, I told you at the beginning. So yes, let's proceed with the problem. Here a 100-watt bulb emits monochromatic light of wavelength 400 nanometer. Calculate the number of photon emitted per second by the bulb. Okay, so definitely here we are going to apply direct formula, energy of photon. Energy of photon. Okay, so that's definitely is going to be E equals to hc by lambda, we can write E equals to hc by lambda. Okay, so now here you can see power is given as 100 watt, right? From here itself we can write this thing as 100 joule per second. Okay, later on we will use this. Okay, at first here let's put the value. Planck's constant value is 6.626 into 10 power minus 34 into, this is velocity of light, 3 into 10 power 8, right? Lambda value is given as 400 nanometer. We will convert it to meter because this unit is taken in meter, right? So 400 into 10 power minus 9. Okay, so if you calculate this, overall calculation will come up to be something 4.969 into 10 power minus 19 joule. Okay, this is something will come. Okay, so now we have to calculate the number of photon. So number of photon, how I should calculate? Number of photon will be the energy, the power, that is 100 divided by the energy, right? 4.969 into 10 power minus 19, sorry. So if you calculate this, your answer will be something like 2.012 into 10 power 20. Here you can see this is joule per second. Here it is joule. Joule will be cancelled out. So second inverse. Okay. So this is how you should target this type of problem. Okay. I guess it's clear to you. Let's proceed further. Okay, so give any three limitation of Bohr's theory. So here are so many. It could not explain the Stark effect, Zeeman effect. Okay, not applicable for the system where I'm having more than one electron. So many things are there. So here you can just take any three of the limitation and you can go ahead. Okay. Here again one more problem. These type of problems are also important. So this is related to the Rydberg's equation basically. What is the frequency and a wavelength of a photon emitted during the transition from n equals to 5 state to n equals to 2 state? Okay, so definitely whenever you will see the transition, this type of thing, 2n value are there. Okay, apply the Rydberg's equation. Okay, so here what I'm going to do at first, see, first energy equation, if we put energy equation is equals to RH. RH is the Rydberg's constant divided by 1 by n1 square minus 1 by n2 square, right? This is the formula. Okay, so always remember, writing the formula will give you 1 mark. Okay, these are the 3 marker numerical problems, right? So writing the formula will give you 1 mark. Okay, putting the proper value in that formula will give you another 1 mark, and whenever you will finish up the calculation with accuracy, that will give you the last mark, and definitely the answer should be with proper unit. Okay, so this is how the 3 marks are distributed in numerical problem. So make sure at least whenever you don't know like how to proceed, how to go ahead, at least write the formula. Okay, and then at least try to put the values. Okay, then calculation part, if you are messing up, okay fine, you are getting at least 2 mark. Okay, this is how the papers are being corrected. So please make sure you are at least writing the formula. Okay, let's proceed. Here we will put the value. So RH value is something like 2.18 into 10 power minus 18, right? So here we will put n1 square is 2, right? N2 is 5. So 1 by 2 square minus 1 by 5 square, right? So I'm not going to the detailed calculation. You can do it. You will get the answer something 4.578 into 10 power minus 18, sorry, 10 power minus 19 joule. 10 power minus 19 joule if you calculate it properly. Okay, it's not yet done. You have to find out the frequency. You just got the energy, right? You have to find out the frequency now, right? So now nu equals to, we know E equals to h nu, that we know. From there I can write nu equals to delta E by h. So from here if you calculate 4.5, I'm rounding off to 58, okay, into 10 power minus 19 joule divided by Planck's constant, right? 6.626 into 10 power minus 34. Okay, so if you calculate this, it will become something, it will coming something like 6.91 into 10 power 14 Hz. Okay, so this is the frequency. So one answer I got, it is related to frequency. Okay, another thing you can see, wavelength. So wavelength, let's calculate again. Wavelength equals to c by nu. Nu equals to c by lambda, no? From there I can write lambda equals to c by nu. From there 3 into 10 power 8 divided by 6.91 into 10 power 14. Okay, so if you calculate this, your wavelength will come up to be something like 434. Okay, 434. So here your answer needs to come in nanometer. So if you just calculate it, it will come in meter into 10 power minus 9 meter. So from there I can write 434 nanometer. That is the answer. Okay, because you can see na, the value you are putting it in the meter unit. The 3 into 10 power 8, that is the velocity of light, you are putting it in meter unit. So your answer will come up into the meter unit. Convert it to nanometer or leave it like that. Okay, if you are confident enough, then only this conversion things you do, otherwise just leave it like that. Okay, I guess you understood these steps. This type of one numerical, please make sure you are practicing. Okay, so here you can see, give the postulates of Bohr theory. 3-marker question you can get. I am giving all the postulates here, but any 3 you remember, any 3 important postulates you remembered out of it. The angular momentum wala postulate, that mvr equals to nh by 2 pi. The stationary state, that thing you remember, and another thing that electron will neither gain or accept energy, that thing you remember. And while it will be given energy, while it will jump from lower energy to higher energy, that time it will take and gain energy, whatever, that thing you mention. Okay, 3 important postulate you remember. Okay, so yeah, here the rest of the things. Here comes the another question you can see. Calculate the wave number for the longest wavelength transition in the Bohr series. Okay, so whenever it comes to the matter of the longest and shortest, okay, just let me tell you, longest wavelength you will get when the transition is the shortest. Okay, and whenever the transition is longest, shortest wavelength you will get, inverse proportion. But same question, if they are asking with respect to frequency, then you have to take the longest transition, because wavelength and frequency again they are inversely proportional. Please make sure, okay, make sure you are going through the question properly. Okay, longest wavelength will come from the shortest transition. Okay, the shortest transition, what type of shortest transition it's possible out there? So basically shortest transition means Bohr series is something that comes, electron comes back in 2, right? So what is the shortest transition possible? 3 to 2, right? So here again I am just going to apply the formula. Nu bar is equals to RH into 1 by N1 square minus 1 by N2 square, right? So you can simply put the values over here. Redox constant 109677. This is the centimeter in inverse unit. Okay, so 1 by N1 square is here 2 square. Okay, minus 1 by 3 square. Okay, so now if you just calculate the entire thing, it will be come up something like 1.5233 into 10 power 4 centimeter inverse. So from here I can write 1.5233 into 10 power 6 meter inverse. That's it. Okay. If you don't want to convert into the meter unit, that's also okay. You can keep it in centimeter. Okay, that's also cool. Okay, I guess it's clear to you. Let's proceed further. Yes. So de Broglie's wave equation that you know, lambda equals to h by p or h by mv. So whenever you are writing any kind of wave equation or any type of equation mathematical form, that make sure that you are writing the abbreviation, what is lambda, what is h, what is p, what is m, what is v, that you have to mention. So here h is the Planck's constant, you know, mass of electron, m is the mass of electron, velocity, v is the velocity of electron, that's it. Okay, so now Heisenberg's uncertainty principle, very important, the postulate and the formula along with the abbreviation. Okay, I'm not just going through again, just remember this is the postulate You have to remember, you just have to, these are the fixed question, you know, these are the what you called as fixed question, that most common question. These are something like that, okay, they directly ask, okay. So please remember the postulates along with the mathematical form. So yes, one problem will come that is related to the Heisenberg's uncertainty principle. Let's proceed with that. Okay, so here the problem is a golf ball has a mass of 40 gram and a speed of 45 meter per second. If the speed can be measured within accuracy of 2%, calculate the uncertainty in position. Okay, so let's do it. So first what you have to do, what is the formula? Delta x into m into delta v. See, mass of the electron is fixed, right, or mass of the golf ball in this particular case, it is fixed. So mass, before mass you can't put delta, okay, equals to h by 4 pi. Okay, here we have to put it. So now what they are saying, mass is 40 gram. So let's put everything over here. Delta x you have to calculate actually. Delta x is the uncertainty in position. So h, let's put 6.626 into 10 power minus 34 divided by 4. Pi value is 3.14. Okay, into mass. Mass is how much it is given? Okay, velocity also we have to put. Okay, so velocity here, some accuracy factor is there, that is 2%, that you have to calculate. So velocity, they are saying 20%, sorry, 2%, right? Velocity they are saying 2% of 45 meter per second. That we have to calculate. Okay, so 2% means 2 by 100 into 45, right? If you just calculate, it will come up to be something 0.9 meter per second. That you have to put there. Okay, so delta v value is coming something like 0.9. Okay, and what is the mass of electron? Sorry, mass of the golf ball here. So here I can take it as 4 into 10 power minus 2. 4 into 10 power minus 2. I guess it's clear because you have to take it in kg. Okay, so now let's proceed. Now let's proceed with the calculation. If you just go ahead, it will give you the delta x value as 0.146 into 10 power minus 32. Okay, so this is the answer. If you want to convert it to like delta x in meter unit, 1.46, you can do it, but this comes in meter. Just a little bit rearrangement, 1.46 into 10 power minus 32 meter. This is the answer. Okay, directly you can put it. So whenever they will give the accuracy, you just have to calculate with the existing velocity. Okay, I guess it's clear to you. Yes, let's proceed. Okay, explain the significance of 4 quantum numbers. So here I have given all the detail out of it, but you can just precisely make sure that principal quantum number will give you the information about the size of the orbitals. Whenever it comes to the matter of azimuthal quantum number, that is L, that will give you the value of angular momentum, or it is also called as, you know, subsidiary quantum number. Okay, it also defines the shape of the orbital, and later if the values are possible 0, 1, 2, 3, right? If it is 0, then it is S, if it is 1, then P, D, then if it is 2, then D, like that you can mention. Then you can directly go ahead with the magnetic quantum number. It gives the spatial orientation, how it is oriented in the 3D geometry, right? And next is spin quantum number. You can just discuss about it, like it gives you the direction of the spin, right? If it is plus half, then clockwise. If it is minus half, then it is anti-clockwise, like this. Let's proceed. Okay, calculate the energy of 1 mole of photon. Okay, so calculate the energy of 1 mole of photon. So how I should calculate? Energy I need, right? So let's put the formula of energy. E equals to h nu. Okay, so E equals to h nu. H value is 6.626 626 into 10 power minus 34 joule second, right? Now what is the new value is given? 5 into 10 power 14 Hertz, right? That is Hertz means also second inverse, right? So second inverse, second will be cancelled out here, okay? And here you will end up with the joule unit. So if you just calculate this, it should come up with 313.3 into 10 power minus 19, okay? 19 joule. So this is the energy, okay? Now we have to find out the energy of 1 mole. So let's calculate the total energy. This is the energy for one photon, right? Now total energy of 1 mole, okay? So individual energy into 1 mole, that is Avogadro number. So energy is something like 3.313 into 10 power minus 19 joule into Avogadro number. If you proceed, that is 6.626 into 10 power 23, right? So yes, if you calculate, it will come up something like 199.51. This is in the kilojoule unit, okay? Kilojoule per mole, like that you will get. Okay, I guess it's clear to you. This is a question taken from the model paper, so it's an important one. Please don't forget to proceed with it. So yes, let's proceed further. Here you can see how many radial nodes and angular nodes are present in 4D orbital, okay? So we know total nodes are basically they can be radial node and angular node. If you just add them, you will get the total node. So now if you know the formula of the radial node and angular node, you will get it. So if I am getting 4D orbital, then for this case L value means N value is 4, right? In case N value is 4 and it is D orbital, it means L equals to 2, right? So from there I can write that angular nodes is directly, it's the number of L itself. So angular nodes, it's basically 2, and radial nodes, if you come up, N minus L minus 1, that is 4 minus 2 minus 1, that will give you 1. If you add them, you will get the total nodes, that is basically 3. I guess it's clear to you. Yeah, let's proceed. Okay, difference between orbit and orbitals, here you can see one is 3D concept and one is simply 2D concept. Okay, just you can go ahead with the differences. Let's proceed. State the Aufbau principle. All the principle, Hund's multiplicity, N plus L rule, all of them are very important, so don't forget. So here comes Pauli's exclusion principle, that is also important. Hund's maximum multiplicity. So whenever you are writing the Hund's maximum multiplicity, please depict with an example. So here you write what actually the correct way to represent the electron, like every particular shell should get 1 1 1 and then it should get paired up, right? So then you also mention the wrong one, okay? So this is the correct way to approach it, and then also you mention the wrong way to approach it, like this, okay? Then the clarification will be better. Okay, I guess it's clear. Let's proceed. Okay, so here comes Vivid Bharati station of All India Radio, Delhi, broadcasts on a frequency of 1368 kilohertz. Calculate the wavelength of the electromagnetic radiation emitted by the transmitter. Okay, so this is a question that came repeatedly, okay? So in like last few years, so that's why I felt to keep it. Here already the problems is solved. Here you can see nu equals to C by lambda. If you simply go ahead with this formula, that is more than enough. So from here you can just simply calculate the lambda value. That's it, okay? Okay, I can see Jeevan, may I know how much can we score? Okay, so definitely if you follow this case, these questions, expected that you will get 60 plus. Okay, so please keep following, it's very important for you. Let's proceed further. So here we are going to start the periodic table. So here comes few questions, few MCQ I kept here. The outer electronic configuration of the most electronegative atom. Most electronegative atom, you know, it's fluorine. So 2p5 configuration. So definitely it's going to be NS2 NP5. Okay, let's proceed. Modern periodic law, very important question. Here you can see IUPAC name. IUPAC name, basically you have to remember after 100, whatever the species, anyone they can ask. Here I gave one example with 120. So this is definitely unbinilium, right? So just remember, anyone can be asked after 100. Okay, so let's proceed. Isoelectronic species. What is isoelectronic species? Means whenever the different species, they are having same number of electrons. So here you can say, I gave the example, all of them are having 10 electron. Okay, here one important question, that is define ionization enthalpy. So how it varies along with the period and along the period and down the group, and also the factors affecting the ionization enthalpy. That is also very important question. Okay, so as you know, for this particular case, the term that is very important, that isolated gaseous atom. Everything you are writing the amount of energy to required to remove the electron from the outermost cell. Then from an isolated gaseous neutral atom, if you don't write the term, it depends on the examiner's mindset if he or she will give you marks or not. So please make sure, that is a key term over there, please make sure that you are writing that. Okay, and this is the trend of ionization enthalpy. Okay, so it increases along the period and it decreases down the group. Okay, remember this, and some factors affecting the ionization energy, that is the Z effective, means effective nuclear charge. So these examples you can give. Okay, so let's proceed. Okay, Kishore, namaste ma'am. In ABHYAS KCET test series, even PCM student had to take biology due to additional burden of price on them. Please ask Deeksha that several students like me need. Okay, definitely I will convey your message to the Deeksha authority, so that this problem can be solved. So don't worry, I will definitely figure something out related to it, don't worry. So your PCM student, yes, definitely once you are just taking the series, you have to take PCMB, all the 4 subjects. Yes, I understood your problem. So yeah, I will just convey your message to the authority. Let's proceed. Okay, so here this type of question related to the ionization energy, it's very important actually. The first ionization energy of boron is less than that of the beryllium. So for this type of question, what happens now, whenever you are writing the electronic configuration, it becomes clear to you. Okay, so for the boron, if you see 1s2 2s2, it's a field orbital, right? But whenever it comes to the matter of beryllium, it's 1s2 2s2 2p1. So 2p1 removal is completely easier than that of the full filled 2s2. So that is the reason basically. Okay, next you can see the first ionization enthalpy of nitrogen is more than that of the oxygen. So that is also the comes up with the same thing. Okay, for nitrogen you can see it's half filled orbital. Okay, half filled orbital means it is basically 2p3 system, and for oxygen it is 2p4 system. So half filled orbital is comparatively more stable, right? So removal of electron becomes difficult for nitrogen. Let's proceed. Here you can see define the electron gain enthalpy. How does it vary? So here you can see the entire thing. Again neutral gaseous atom. Please make sure you are writing it. Okay, let's proceed. The electron gain enthalpy of oxygen or fluorine is less negative than that of the succeeding element of sulfur and chlorine. Very important question for this year. Okay, the electron gain enthalpy for oxygen and fluorine is less negative than that of the succeeding element sulfur and chlorine. Why? Because of the availability of orbitals. To oxygen and fluorine, they are smaller in size, they are having only 2p orbital, but whenever it comes to the matter of sulfur and chlorine, they are having damn 3d vacant, right? So they can accommodate electron over there. So here you can see the reason over there, it's written here, higher region of space. Okay, let's proceed. This question is also important. This question also was given probably in the model paper in the form of an MCQ. Okay, so yes, let's proceed. Which of the following will have the most negative electron gain enthalpy and the least negative? So most negative electron gain enthalpy is definitely chlorine, and less negative is definitely going to be phosphorus. Okay, let's proceed. Okay, here we are going to start the next chapter, that is chemical bonding. Okay, just let me take a sip of water. Okay, so whenever it comes to the matter of chemical bonding, some important problems. Okay, first let's do the MCQ. All the dash species have the same bond order, isoelectronic species. Okay, if the number of electron is same, then the bond order comes similar. Next, the shape of the water is going to be trigonal bipyramidal. Yes, people are so much obsessed to write bent. Okay, don't do it. Consider the lone pair of water as well. Okay, then it will come up like that. Okay, let's proceed. Here you can see which of the following molecules, okay, wait just a minute, shape they are asking. Geometry, when they are asking, you can just go ahead with the trigonal bipyramidal, but shape you can mention about the bent. Okay, yes, let's proceed. Okay, which of the following molecules geometry is true? See, here they have given the geometry. So geometry, whenever it comes, then trigonal bipyramidal or whatever, those things will come. Okay, so here you can see BRF5, trigonal bipyramidal, it's correct. CLF3, it's T-shaped, that is also correct. PCl5, if you see, that is also trigonal bipyramidal. Okay, means if I just draw the geometry, P, here one Cl, here one Cl, this is your triangle, right? One Cl up, one Cl down. Okay, so now if you connect all the corners, it will give you TBP. It will give you the TBP geometry. Okay, so this is the wait, which of the following molecules geometry is true? Wait just a minute. The question, I guess it's having something glitch in it. CLF3 is also true. Trigonal bipyramidal is seesaw. That is also, it should be wrong actually. It should be false, because PCl5 will give you the seesaw. It doesn't give you the seesaw geometry. It gives you trigonal bipyramidal. Okay. And SF4, if you just see, SF4 also trigonal bipyramidal because of the lone pair. Yes. Let's go ahead. Here you can see the angle between two bonds in linear molecule. So whenever the molecule is linear, so it's going to be 180-degree angle in between them. Okay, so let's proceed. Calculate the formal charge on each oxygen. This is a very common question that comes out of NCERT. Okay, so here you can see 3 different oxygen. If you simply put the formula for the 3 different oxygen, whatever the existing charge, that will come up. Okay, so let's proceed. What is a Lewis symbol? Okay, give one significance of this symbol and write the Lewis symbol of ozone molecule. So Lewis symbol, this particular question is taken from the model paper itself. This is the Lewis symbol of ozone molecule. So Lewis symbol is a type of symbol where the valence electrons are visualized in the form of dots. Okay, like this. You can see oxygen valence electrons are given like this with the form of dots. So this is actually the Lewis symbol. Okay, so I guess it's clear. Let's proceed. Limitations of octet rule, you can see here. First is inert, first is some cases not necessarily octet, means outermost orbital is getting 8 electron, right? That is the main motto for the octet rule, right? But some cases we can see like PF5 SF6 molecule, we see the valence orbital is containing more than 10 electron or more than 8 electrons, sorry, more than 8 electrons. So those cases, these are the exceptions, and less electrons are also present. Those cases we can also see, like you can see LiCl, BeH2. Whenever it comes to the matter of BeH2, it is only having the 2 electron, right? So 2 electron means it is lesser than that of the 8, right? Another case, sometimes you can have odd electron as well, okay, like NO, NO2, okay, that is also against the octet rule. So these 3 examples you can just keep. Okay, next CO3 2 minus, the resonating structure you can see. You can just draw these 3 consecutive resonating structure accordingly. Okay, let's proceed. BF3 molecule dipole moment is 0. What is the reason behind it? Here you can see BF3 molecule is trigonal. So here one fluorine, here one fluorine, here one fluorine. For these 2 fluorine, the resultant dipole moment comes something like this direction, right? As a result of this boron fluorine dipole moment and this one, the resultant one, will cancel out each other. Okay, so as a result you will get 0 dipole moment. Let's proceed. The defined dipole moment and unit, you can see it's dBi. Proceed ahead. The resultant dipole moment of NH3 is greater than NF3. What is the reason behind it? If you just look at the diagram, it will be clear to you. Nitrogen lone pair direction is upward, so lone pair direction, I mean the dipole moment direction will be upward as well, and nitrogen hydrogen bond dipole moment is towards nitrogen, right? But if you just look at the fluorine, so nitrogen and fluorine, who is more electronegative? Fluorine. So it will be towards fluorine, and above will be for the lone pair. So above and below, they almost cancel out each other. Okay, they can't cancel out completely. You can see very small dipole moment, 10 power minus 30, very small dipole moment we can get, but compared to that of, it's very small. Okay, so I guess it's clear. So that's the reason NH3 is having greater dipole moment than that of NF3. NF3 to some extent it is getting cancelled out. Okay, let's proceed. VSEPR theory, main postulates, please remember main 3 postulates you note down. Okay, they ask direct question. Remember that we consider the molecule to be spherical. The valence shell electrons are positioned on the sphere of the electron. Interaction, you have to mention that the electrons of the valence shell, they undergo some repulsion between them, right? And the repulsion is in which order? Lone pair, then lone pair, bond pair, then bond pair, bond pair. So like that you can proceed. Okay, 3 main point you have to proceed. So yes, let's go ahead. It's a question taken from your model paper, so very important. Okay, the bond angle of SO2 molecule is less than 120 degree. Why? The reason is basically the lone pair bond pair repulsion. So basically if you just draw the structure, it is like that. Okay, so this lone pair and pi electron cloud, okay, they repel each other and makes this bond angle smaller. Okay, so lone pair bond pair repulsion is the reason. The shape is V-shaped. Okay, let's proceed. Mention 2 factors that determines the percentage covalent character of an ionic bond. First is size of the ions. It is in accordance to the Fezan's rule. Okay, this question also is taken from your model paper, so don't forget to go through it. And another thing is charge of the ions. Okay, let's proceed. Next question, here you can see the VSEPR, in accordance to the VSEPR, the shapes of BeCl2, BF3, CH4, NH3 and H2O. So here comes the detailed explanation. I'm just telling you in a very brief way. BeCl2, definitely it's a linear molecule. Okay, and further if you go ahead, BF3 just now we discussed while discussing the dipole moment, it's trigonal planar. Next, if you proceed with the ammonia, this is the geometry of ammonia. You can say tetrahedral, but I will not suggest to like call it tetrahedral, because in proper tetrahedral the bond angle comes 109.5, but because of nitrogen lone pair bond pair repulsion, the bond angle reduces to 107.5. The bond angle, these cases, please remember, water, ammonia, SO2 molecule, bond angle you have to remember. Okay, so yes, these are the things, and here comes the water. This is the geometry of water and the bond angle of water, that is 104.5 degree. Here what happens basically, this is also we are a trigonal pyramidal shape, trigonal pyramidal, not bipyramidal, trigonal pyramidal is the geometry of water. So in case you are just mentioning it in form of shape, it will be more accurate because it doesn't follow the proper geometry because of the lone pair followed by lone pair bond pair repulsion. Okay, that reduces down the angle from 109 to 104.5. Okay, remember these things. Let's proceed. Okay, difference between sigma and pi bonds you can just go through, axial overlap, lateral overlap, these things you can just go through. Okay, important problem, 2 marker usually they ask sigma and pi bond difference. Next, sp hybridization of acetylene molecule. So basically here if you are having the carbon atom in the center of this thing, so carbon is sp hybridized out of it. Carbon is sp hybridized. So one carbon and another carbon sp hybrid orbital will overlap to give you the sigma bond. Okay, and another 2 p orbitals are there. Let's say px is forming the sp hybrid. Okay, so px is involved in the sp hybrid and they are further overlapping to give you the sigma bond, right? So py and pz is still there. So py and pz of 2 different carbon, they will overlap laterally to give you 2 different pi bond. That you have to explain like this. I guess it's clear. Let's proceed. SF6 geometry, that is also very much important. sp3d2 geometry, hybridization. So what basically happens, if you just look at the sulfur electronic configuration, it's basically 3p2 let me just draw it for you, the valential electronic configuration. I get 3s2 and 3p4, right? Like that. This is the geometry. So 3s, this is my 3p, and 3d is vacant. There is no electron in 3d. Okay, so what happens whenever it's pairing up with the fluorine, unpairing of electron takes place. One electron from p, it comes to the d, and another electron from s, it comes to d. It becomes like this. So now all the orbital, they paired up with fluorine. Okay, so thus all the 1s, 3p and 2d orbital, they gets combined and makes the hybrid orbital sp3d2. Okay, so I guess it's clear to you. Okay, let's proceed. Write the 3 conditions for the linear combination of the atomic orbitals. It is also very important because it is taken from your model paper. Okay, first is similar energy level, same symmetry and maximum overlap. Okay, these are the main thing. Next you can see this thing, very important. This type of question comes actually, it's also I guess taken from your model paper. Okay, so the starred carbon, the marked carbon, you have to tell the hybridization. So this carbon you can see, so for this case count the steric number of sigma bond it is forming, because for carbon there is no lone pair, so number of sigma bond you count. Okay, for this it is coming 3, so sp2, for this case it is sp3, for this case it is sp. Let's proceed. How many types of bonding and anti-bonding molecular orbitals are formed in diatomic molecules? So here you can see bonding, sigma bonding, pi bonding, sigma star anti-bonding, pi star anti-bonding. That's it. Okay. Let's go ahead. Okay. So here a very important question. Why helium does not exist in the form of He2? Okay, why? Because the overall bond order, it comes up to be 0. So if the bond order comes 0, means there is no bond formation at all. Okay, so in that case you have to draw the MO diagram, you have to find the bond order with the formula, you have to show it that it's coming 0. That's the reason it comes like He2 does not exist, like that you have to explain it. Okay. Okay, let's proceed. So this is for the MOT for the oxygen. So oxygen and carbon, I suggest you oxygen, carbon and nitrogen. Oxygen, C2 and N2. All of them you go through, all these 3 you go through, any one you can expect in your examination. So I am showing you one of it. So here the question is related to oxygen, that's why I am showing. Here you can see, first atomic orbital of oxygen we will do. So this is 1s. So atomic orbital of oxygen, this is also atomic orbital of oxygen, and here we will do molecular orbital of O2. So it will combine to give you 1 sigma bonding, 1 sigma star antibonding. So this is sigma 1s, this is sigma star 1s, means antibonding. Now similarly I will be having 2s. So 2s, 1 will give you the bonding. This is your 2s orbital, 2s, sigma 2s, sigma star 2s. Okay, next you will be having py, right? So 2px, 2py, 2pz. Here also 2px, 2py, 2pz. So if you combine, at first you will get 1 sigma bonding. Sigma, let's say 2px is making the bonding. Next you will get pi bonding. Let's say if px is forming the bonding, then px is the sigma forming, then py and pz is forming, py and pz is forming the pi. So pi to py and pi to pz, right? Further, pi star, this is pi star to py, pi star to pz, and finally sigma star 2px. This is the entire MO orbital. Okay, so let's proceed with the electron fill up. 1s2, 2s2, 2p4, right? Okay, so now in the same way we are going to fill up this as well. 1, 2, 3, 4. 3, 4. Here also we will follow the Hund's rule. Total 8 electron, right? So 1, 2, 3, 4, 5, 6, 7, 8. So here you can see this particular orbital is basically HOMO, highest occupied molecular orbital, and it is containing unpaired electron, and hence you can call it paramagnetic. Okay, so oxygen O2 molecule, it exists in paramagnetic in nature. Okay, so I guess it's clear to you, and here comes the entire electronic configuration. See here, like that, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, like that you can proceed. Okay, this is how you will get the electronic configuration. Now one more thing it comes out of it, that is a bond order calculation. So half into bonding minus anti-bonding, if you do, you will get the bond order. For oxygen it comes up to be 2. Okay, I am getting a question from rank pusher. Okay, will we get fixed question like physics that is there in the channel? It is like 12 minutes video. Yeah, definitely we will come up with the fixed question video, but the thing is in the fixed question video we will get the questions only. The numerical problems we will not get out of it. It's only the theoretical questions will be assembled over there. Definitely after this session, maybe in 1 or 2 days you will get for chemistry as well. So yeah, you will get it. Let's proceed. Okay, explain the types of hydrogen bonding. So definitely intermolecular and intramolecular. So you can give the example of either water or HF, and for intramolecular you can give the orthonitrophenol example. Okay, let's proceed. Okay, so I found student, they tell me that they keeps telling like thermodynamics is very difficult, they don't understand and all. So here I am going to solve the majorly the numerical problems out of it. What are the most important zoned numerical? So please keep focusing. First, a little bit MCQ. The entropy of the system increases in the order. Okay, first gas, then liquid, then solid. Okay, let's proceed. Okay, next you can see a spontaneous reaction is not possible. Okay, so for this case you have to proceed with the formula delta G equals to delta H minus T delta S. Okay, so spontaneous reaction is not possible. For a reaction to be spontaneous, del G should be negative, but whenever the reaction is not spontaneous, del G must be positive. So I have to check in which case del G will come positive. Okay, first case, del H and T del S both are negative. So if both are negative, del H is negative, this is also negative, negative comes positive. Now if enthalpy value overcomes, if enthalpy magnitude is more, then it can give you the del G negative value. So there is a possibility of del G can be negative. So we can't tell that. Next, del H and del T del S both are positive. So let it be positive, and this value is positive. So positive, negative, negative. Then let's say T is very high, temperature is very high. Then this overall negative value will give you del G as negative. So reaction is spontaneous. Now del H is positive and T del S is negative. Okay, del H if it is positive and T del S is negative. So negative, negative, it comes positive. So overall the things comes positive, right? There is no possibility that del G can be negative here. Del H is also positive and T del S is negative. So negative, negative also positive. So it cannot be spontaneous. Option C is the correct one. I guess it's clear. Let's proceed. Okay, I can see that Jivan is saying answer is D. Del G is negative and T del S positive. Okay, let me explain you, my dear. If del H is negative, okay, and T del S is positive, so positive, negative, this thing will be negative, right? And this is also negative. So overall the things will be negative only, right? So del G will be negative, right? I guess it's clear. Let's proceed further. Okay, the enthalpy of all the species in their standard state is basically, 1 minute, just a minute. Okay, so the enthalpies of all elements in their standard state, that is always 0. Okay, let's proceed further. What is the adiabatic process? The definition is given, is important one for you people. Let's proceed. First law of thermodynamics, mathematical form is also very important. Next is, you can see what is free expansion. It's a very important question. Okay, when the expansion is taking place in vacuum, there is no external pressure. Okay, so work done is definitely going to be 0, right? Next, okay, this type of numerical problem we will focus. Okay, let's proceed. A gas absorbs 120 joule of heat and expands against an external pressure of 1.10 atmosphere from a volume of 0.5 liter to 2.0 liter. Okay, what is the change in internal energy? Okay, so let's go ahead with this problem. So we are going to apply the first law here. Delta U equals to Q plus W, right? Okay, so here Q is given as 120 joule because gas is absorbing heat, right? And expansion is taking place, so it is plus 120 joule we can take, and the W is basically equals to minus P external V2 minus V1. Okay, so let's calculate. External pressure is given as minus 1.10. Okay, 10 into 2 minus 5. Okay, so from here I am getting 1.5, so minus 1.10 into 1.5. Okay, as a result of this you will get something like minus 1.65 liter atmosphere. Okay, so liter atmosphere we will not work with, we will convert it to joule. In order to convert it to joule we have to multiply with 101.3. Minus 1.65 into 101.3. If you go ahead, the work done will be something like minus 167.145 joule. Okay, so this is the work done. Now let's put everything in this equation. So delta U I have to find out, equals to Q value is plus 120. Okay, plus minus 167.145. Okay, so if you calculate this, your answer will come something like minus 47.135 joule. That's the answer. Okay, I guess it's clear. It is actually depending upon the first law only. Okay, let's proceed. Okay, here comes one more problem. Calculate the total work done when 1 mole of a gas expand isothermally and reversibly from an initial volume 20 decimeter cube to a final volume of 40 decimeter cube. Okay, so just apply the formula here. Work done formula for the isothermal process, I guess you remember, work done equals to minus 2.303 nRT log V2 by V1. Right, now put the value. So minus 2.303, here N is 1 mole, right? Okay, let's put the value of R, 8.314 into temperature is 298 Kelvin into log 40 by 20. Okay, so now if you just calculate the entire thing, this will come up to be log 3, right? Log 3 value is 0.301. So 2.303 into 8.314 into 298 into 0.301. So overall if you calculate, it will come up to be 1717.46 joule per mole. Okay, direct application of this particular formula. So as I told you earlier as well, just please make sure you are writing the proper formula and you are putting the proper value. Okay, so let's proceed. Okay, so here comes the next problem, that is the reaction of cyanamide with oxygen was determined in a bomb calorimeter, and delta U was found is given. Okay, the cyanide. Okay, calculate the enthalpy change for this reaction. So this type of numerical is also important. So this is a numerical that is also important for your competitive examination as well. Okay, so yeah, let's proceed. So for this case we have to find out at first delta N. Okay, why? No, because my formula that I am going to use, whenever you will see that bomb calorimeter this term is given, we have to use the formula delta H equals to delta U plus delta Ng into RT. This formula we have to proceed with. Okay, delta Ng means product minus reactants, the stoichiometry of gaseous product minus gaseous reactant. Okay, so NP minus NR, all of them should be gaseous only. So here I am having product is 2 minus 3 by 2, right? Because NH4CN, NH2CN we are not taking because it is solid. Okay, and H2 we are also not taking because that is liquid. So it will give you 0.5. Okay, let's put everything here. Okay, delta U value is given minus 742 minus 742.7 kilojoule. Okay, plus 0.5 mole plus 0.5 mole into 8.314. See, here I am putting the value in kilojoule, right? So that's the reason I am multiplying this with 10 power minus 3. So the unit will come up to be kilojoule Kelvin inverse mole inverse, right, into 298 Kelvin, right? So if you calculate everything, okay, I guess the unit portion you understood. If you calculate everything, it will come up to be something like minus 741.46 kilojoule per mole. That is the answer. I guess it is clear to you. Okay, let's proceed further. Okay, calculate the standard change in internal energy at 300 Kelvin for the reaction. Okay, so for this type of case, again enthalpy of the reaction formula we are going to use. So what is the formula? Enthalpy change for the reaction is going to be summation of the enthalpy of the product minus summation of enthalpy of the reactant. Okay, so what are the product here? CO2 and HCl. So corresponding value we will put here. Okay, so for the CO2 the value is minus 394. Okay, so minus 394 plus 4 into HCl, right? 4 into minus 93. 4 into minus 93. Okay, this is my product portion. Now let's write the reactant. Reactant you have to start with CCl4. So CCl4 is given minus 107. So minus 107 minus, see, 2 of H2O, so 2 into minus 242. So 2 into minus 242. Okay, this is the thing. Overall it will come up to be kilojoule per mole. So if you calculate this thing, it will come up to be something like this, minus 175 kilojoule per mole. Okay, it's not yet done, wait, because you have to calculate the internal energy, right? So we only came up with the enthalpy value. So now enthalpy is basically equals to del U plus Ng delta Ng RT. Okay, here I have to put the value. So from here I can write delta U equals to delta H minus delta Ng RT. Let's put the value here. Okay, Ng, delta Ng value is coming something like 4 plus 1, 3. So it is coming 5, sorry, 4 plus 1, 5 minus 2, it is coming as 3. Okay, now let's put the value here. Delta H is coming 175 minus 175 kilojoule per mole. Okay, minus 3 into 8.314 into 10 power minus 3 kilojoule per Kelvin per mole into the temperature is given as 300 Kelvin. Okay, this is the entire thing. So if you calculate, your answer will come up something like minus 182.5 kilojoule per mole. That is your answer. Okay, I guess this thing is clear. First, from the enthalpy of reaction, you calculate the enthalpy value, then put it into that equation in order to get the internal energy. Okay, so yes, let's proceed. Okay, derive the relation between Cp and Cv. Super important question, my dear. Don't skip. So here we know from Q we can start. Q is basically, Q is the heat, E is equals to C into delta T. Right. So from here, if you find out Q in at constant V, it should be Cv into del T. And if you find out Q into in constant pressure, it will be Cp into del T. So I am having equation 1 and equation 2. Let it be. Okay, now I am having the equation again, that bomb calorimeter wala equation or normal enthalpy equation you can take. Delta U plus delta RT for 1 mole. Okay, I am avoiding the N. So delta H, let's put. Delta H is nothing but Cp, nothing but this. This is also called delta H, right? Okay, so I can write Cp into delta T, and this is also called delta U, right? And delta U we can write Cv into delta T equals to R into delta T. Wait. Plus R into delta T. So from here, if I take delta T as common, from here I will get Cp equals to Cv plus R. From here, Cp minus Cv equals to R. That is the derivation. Okay, so I guess it is clear. Let's proceed further. Okay, enthalpy of the reaction, definition important. Molar enthalpy of fusion is important, and another thing is atomization, enthalpy of atomization. So all the answers you will get out of it. Okay, one more problem, calculate the enthalpy of combustion of liquid benzene. Okay, this problem is very much important, highly demanding question. Okay, also there in your model paper. Okay, so let's proceed with this problem. So CO2, H2, the formation of benzene, CO2 and H2 are given. You have to find out the enthalpy of combustion of liquid benzene. Okay, so what are the equation? See, formation of benzene, CO2 and H2 are given. At first, formation equation for benzene, CO2 and H2, let's write. Okay, so if I write the formation equation, so first is benzene, so carbon plus hydrogen will give you benzene, C6H6. Let's balance it. 6C plus 3H2. Okay, so for this case the enthalpy value is given. The enthalpy value is given as formation enthalpy, that's why H naught I am writing. It's given as 48.51 kilojoule. Okay, next is carbon dioxide. C plus O2 will give you CO2. So delta H0 is given as minus 393, is given as minus 393.5 kilojoule. Next is given as water. Okay, H2 plus half O2. Okay, this is already balanced. Okay, plus half O2 will give you H2O liquid. Okay, so for this case delta H naught is given as minus 285.83 kilojoule. So let it be equation number 1, this is my equation number 2, this is my equation number 3. Okay, and what is the main equation? That is a combustion of benzene. There I have to come up utilizing this 3 equation. Okay, so the main equation is something C6H6 plus O2, combustion of benzene, right? Then you will end up with 6CO2 plus water. Okay, let me balance it a little. It should be 15 by 2. Here it should come 6. Okay, this is 3. This is the main equation you have to come up with. Okay, for this case you have to find out the delta H. Okay, so now how you should plan to arrange these 3 equations to come up with the final one. Okay, what you have to do? Just proceed. Equation 2, this equation 2 I am multiplying with 6. Okay, plus let's say equation 3 I am multiplying with 3 plus reverse of equation 1 I will take. Okay, so let's write it one by one. 6CO2 6C, sorry, 6C plus here it will come 6O2. 6O2 will give you 6CO2. Okay, so enthalpy value also will be changed. So enthalpy value will come up to be something like that into 6. So minus 393.5 into 6. If you calculate this, it will come up to be something like minus 2361 kilojoule. Okay, next equation let's write 3 of H2 plus 3 by 2 of O2 will give you 3H2O. For this case you have to multiply this thing with 3, right? Okay, so minus 285.83 into 3. If you do this, this will come up to be something like minus 857.49 kilojoule. And reverse of equation 1. So it will come up as C6H6 will give you 6 carbon plus 3H2. Okay, and whatever the value you can see, it will be also in the form of negative sign. So minus of 48.51 kilojoule. Now add them. So while adding you can see so many things will be cancelled out here. Okay, 3 by 2 O2 will be cancelled out. Here I am getting H2, right? So 6 carbon will be cancelled out. Wait, 6 carbon, yes, plus 6 carbon. Okay, 6 carbon will be cancelled out here, and here hydrogen will be cancelled out. Okay, so I guess it's done. Yeah, let's proceed. You can see C6H6 overall plus, now if you just minus this thing, overall it will come 15 by 2 O2 will give you 6 CO2 plus 3 H2O. Okay, 3 H2O. Now if you add these values, it will come up to be something like minus 3267 kilojoule per mole. That is the answer. Okay, a little bit patience you have to keep for this case. This value plus this. Okay, if you add them, then it will come up to be something like this. Okay, I guess it is clear to you. let's proceed. Okay, so this is the Gibbs equation, Gibbs-Helmholtz equation. So they ask you to write it, and please make sure you are mentioning the abbreviation as well. Okay, so next question, counter question is, what are the conditions for del H and del S for a reaction to be spontaneous at all temperatures? So definitely del H always must be negative and del S is positive. So if it is negative and if it is positive, positive, negative, negative, so overall the value will always be negative. Okay, let's proceed. Okay, we will start up with the equilibrium chapter. Okay, so see, here comes the question, derive the relation. Derivation of this relation will not come, rather just deduce the relation means you just have to write down, okay, what is the relation between them. Kp equals to Kc into RT power del N. Derivation part, hopefully it will not come, I am not proceeding with it. Okay, next question, you can see it's a numerical problem related to that equation only. Calculate the Kp for this case. For equilibrium constant, Kc value is given. Okay, so Kp Kc relation we know, from there we can calculate this. So Kp equals to Kc into RT power del N, right? So from here, if you just calculate the delta Ng value, delta Ng means always you have to take the gaseous thing only, gaseous product and reactant only. 2 plus 1, 3 minus 2, so it is coming 1. Now put the value 3.75 into 10 power minus 6 into 0.0831 into T value is how much? 1069 power 1. Okay, so if you just calculate this, it will come up to be 0.000333. That's it. Okay, simple calculation. Let's proceed further. Okay, application of equilibrium constant, very important. You can just go through from here and you can just take the application, the prediction of the extent of reaction, okay, calculating the equilibrium concentration, like that. Okay, here what is reaction quotient? Reaction quotient means it is definitely the concentration of product by reactant, but at any instant. Okay, it's not at equilibrium condition. Proceed. The relation, like how do you predict the direction of the reaction of equilibrium constant and the reaction quotient? This is very important question. Whenever QC is greater than Kc, the reaction is basically towards the reactant, means backward direction. If QC is lesser than Kc, then it is forward direction. If they are equal, then they are in equilibrium. Okay, this diagram, on the basis of this diagram also they can ask you what can be the direction. Okay, so yes, let's proceed. Okay, one more problem. Okay, let's proceed. A mixture of 1.57 mole of N2, 1.92 mole of H2 and 8.13 mole of NH3 is introduced to a 20-liter reaction vessel. Okay, at this temperature the equilibrium constant Kc for the reaction is given. Is the reaction mixture at equilibrium? If not, what is the direction? Okay, simply you have to just find out the value and you have to compare it with the Kc. That's it. Okay, so QC, if I calculate, QC for this case if I calculate, so definitely that's going to be NH3 whole square divided by H2 whole cube into N2. Put the value, that is 8.13, right? Okay, so here you have to put the concentration, right? And there they have given in terms of mole, so you have to divide it with the volume, right? So volume is 20, right? 20 mole per liter, 20 liter, you can see. Okay, so 8.13 divided by 20. Here also I can write 1.57 divided by 20. Here also I can write 1592 divided by 20. So if you calculate this entire thing, okay, square this is cube. If you calculate this entire thing, it will come up to be something 2.38 into 10 cube. Okay, so now definitely this is not equals to Kc. The Kc value is given, you can see this one. Okay, rather I can tell that Qc is greater than Kc. So now what is the condition? So if Qc is greater than Kc, then the reaction will be driven towards the backward direction. I guess it's clear to you. Let's proceed further. Okay, Le Chatelier principle, very important, direct they can ask. Next you can see explain the effect. All the effect of pressure, temperature, effect of concentration and effect of addition of inert gas, all of them are important. Okay, so explain the effect of pressure in this equilibrium. So whenever you are applying pressure, always remember the reaction will move towards that direction where there are lesser number of molecules. Okay, so if you add pressure over here, check where there are lesser number of molecules. In the reactant side I am having 3 plus 1 4 moles and here I am having 2 moles, right? So definitely the reaction will proceed towards a direction where there are lesser number of moles. Reaction will be proceeding towards a forward direction. Okay, go through it, I guess you will understand. Okay, proceed, go ahead. The equilibrium remains undisturbed by addition of inert gas at the constant volume. Why? The reason is basically inert gas, they don't take part in the reaction, right? So concentration, as the volume is fixed, the concentration will not change, right? So it is not contributing in the molar concentration. That's the reaction. That's the reason the reaction, the equilibrium remain undisturbed. Okay, let's proceed. What is the effect of change in temperature in equilibrium? It's a very important question. So in case you are having exothermic reaction, if you increase the temperature, reaction will be backward. Why? Because it will try to utilize the temperature, and if the forward is exothermic, backward is endothermic. So endothermic is temperature required process, right? Now if your reaction is endothermic, then if you give temperature, your reaction will proceed forward direction. That's it. Okay, I guess it's clear. Let's proceed further. Okay, what is the effect of catalyst in the equilibrium? Definitely a catalyst has no role while the equilibrium is already established. So catalyst, whenever you are putting, it will help you to reach the equilibrium faster. At that time the forward reaction rate and backward reaction rate, both of them will be increasing in a similar way, right? So at the equilibrium point you will not see any role of the catalyst, rather you will see the role of catalyst when it is reaching, it is not yet reached, whenever it is going towards the equilibrium. Okay, I guess it's clear. Let's proceed. Okay, what will be the conjugate basis? Okay, what will be the conjugate basis for the following Bronsted acid? Okay, so for this case definitely Bronsted acid conjugate base. Okay, so conjugate base means after acid, after releasing its H plus, so HF it will form F minus, H2SO4 it will form HSO4 minus, HCO3 it will form CO3 2 minus. Okay, just release one hydrogen from it, that's it. Okay, BF3 is a Lewis acid, NH3 is a Lewis base. This is the reason, because nitrogen is having a lone pair where boron can accept electron. Okay, let's proceed. Okay, here comes a question. It is taken from the model paper, I guess. What are the effects of the following condition on the equilibrium for a given reaction? Okay, first is addition of argon gas at constant volume. Okay, so as I told you, if you keep the volume fixed, there will be no change. Okay, now increase in pressure. If you increase in pressure, it will be diverted towards a direction where there are lesser number of moles. So if you increase in pressure, it will drive towards a forward direction. Okay, I guess it's okay. Let's proceed. Okay, it's a very important thing, the relation between pH and POH. So how you should prove it, how you should derive it? See, H plus into OH minus, this is nothing but the Kw. What is Kw? Kw is 10 power minus 14, right? Okay, so now from here, if you just take log both side, so minus log of H plus minus log of OH minus equals to minus log of 10 power minus 14. If you put everything properly, then you will see this is nothing but pH, this is nothing but POH, and this is basically 14. That's it. I guess it's clear. Let's proceed. Okay, so one problem is there. Acetic acid, calculate the pH of 0.1 molar acetic acid. The dissociation constant of the acetic acid is given. Okay, so what is the formula? Acetic acid is a weak acid. So weak acid, the concentration of H plus formula is basically under root Ka into C, right? Now if you put the value over here, that is 1.8 into 10 power minus 5, right? Minus 5 into 0.1. If you calculate this, it will come up to be something 1.341 into 10 power minus 3. Now pH calculation, so minus log of H plus, if you calculate minus log of H plus means minus log of 1.34 into 10 power minus 3. If you calculate this, your answer will come up to be something like 2.876. That's it. Okay, I guess it's clear. I'm not going to the depth of the calculation because log table will be provided for your board examination. If you know how to check the log table, then it will be easier for you. Okay, let's proceed. Okay, what is common ion effect? Give an example. It's in accordance to the Le-Chatelier principle actually. If the common ion of an weakly dissociated compound or electrolyte is present, then the dissociation will be further suppressed. One example is given with respect to acetic acid. If you give sodium acetate in acetic acid, because of the presence of same ion, CH3CO minus common in both cases. So now CH3CO minus is excess, so reaction will go backward. That is a common ion effect. Proceed. What is a buffer solution? Give example. So buffer solution is what? It is a type of solution. It resists the change in pH whenever it is added, like whenever a small amount of acid or base is added to a solution by mistake, then it resists the change in pH. That is a buffer solution. So there are different type of buffers. You can see acidic buffer example, CH3COH plus its conjugate base, CH3CONA. Next, basic buffer, NH4OH plus NH4Cl. Neutral buffer, you can see ammonium acetate. Okay. Henderson-Hasselbalch equation, sometimes they directly ask you to write. This is the equation. Okay. Next, one problem. It's not a problem, question. First, you can see PCl5 is giving PCl3 plus Cl2. First is addition of Cl2. Addition of Cl2 means you are adding more product. So more product if you add, then the reaction will go backward because product side concentration will be more. Now you can see decrease in volume. If you decrease in volume, pressure will be increasing. So if you increase the pressure, the reaction will be diverted to a direction where there are lesser number of moles. So reaction will divert towards back side. Okay. Next question, here you can see one numerical problem. Let's go ahead with it. Okay. What is the question? The solubility of BaSO4 is 2.33 into 10 power 4 gram per ml. Okay, look at the unit, it's gram per ml. We have to change it. At 20 degrees Celsius, calculate the solubility product. Okay, so how I should do it? See, we know KSP, it is an AB type of salt, BaSO4, right? So BaSO4, if you simply break down, it will give you Ba2 plus SO4 2 minus. Okay, so KSP is basically equals to A square because this is S, this is S. Okay, so from here S is given as 2.33 into 10 power 4 gram per ml. Okay, so now what I'm going to do is 2.33 into, we are going to convert it to mole per liter. Okay, 10 power 4. So in order to convert it to mole, you have to divide with the molecular weight. So molecular weight of BaSO4 is 233. Okay, so that will give you the mole. Okay, now per liter means here you have to do 10 power 4. Oh, it's already there. I have already mentioned here. So simply you have to divide with 10 power minus 3. Yes. So overall if you do it, it will come up to be something like 1 into 10 power 5 mole per liter. Okay. So now calculate the KSP again. So KSP will be 1 into 10 power 5 mole per liter whole square, right? So it will be 10 square, I mean 5 square. So 5 square nahi, 5 into 2, right? So 10 power 10 mole square and a liter power minus 2. That's it. So that's going to be your KSP value. I guess this thing is clear to you, BaSO4. Okay, let's proceed further. Okay, find the pH of a buffer solution containing 0.20 mole per liter CH3CONA and 0.15 mole per liter of CH3COOH. Okay, so here whenever you will see buffer solution, you can simply add Henderson-Hasselbalch equation. Okay, so definitely it's going to be pH equals to pKa plus log of concentration of salt by concentration of acid. Okay, now what I'm going to do is pKa calculation I need to do here. Okay, so pKa I can do like log of 1 by Ka, because minus log of K, right? So log of 1 by Ka I can do. So 1 by 1.8 into 10 power minus 5. Okay, so if I calculate this, it will be something like log of 0.55 into 10 power 4. Okay, 10 power 4. So yeah, let's calculate 0.5. This will give you 4. This will give you 0.7, I guess. Okay, if you calculate 4.7, you will get from here. Let's put it here. So pH is going to be 4.7 plus log concentration of salt is 0.15. Okay, 0.15 I am directly writing because it is, though it is given in mole per liter, liter will be cancelled out anyway. Okay, 0.15 divided by 0.20. Solution containing 0.20 mole per liter of this. Okay, just a reverse thing I wrote. .2 divided by 0.15. Okay, so simply if you just calculate, you will get the answer. I am not proceeding further, okay, because it will be a simple calculation. Okay, let's proceed further. Okay, we will proceed with the redox reaction. 3 more chapters we are having. Let's go ahead. Okay, so here you can see which of the best description of the behavior of bromine in the reaction given below. Okay, this question previous year, yeah, probably it was a previous year question. Okay, so H2O plus Br2 gives HOBr and HBr. So if you see here, bromine is -1 oxidation state and here it is +1 oxidation state. Okay, so now from here you can see this is 0 oxidation state and this is +1, this is -1, means it's a type of disproportionation reaction. 0 to -1, it's gaining electron, right, means reduction. 0 to +1 means it is an oxidation, right? So both oxidized and reduced. Proceed. The oxidation state of H4IO6 minus. Okay, you can simply calculate. I you can take as x, so 4 into 1 plus x plus 6 into -2 will give you -1. Okay, 4 plus x minus 12 will give you -1. So x is basically -1 plus 12 minus 4. Okay, so it will give you x equals to plus 7, right? Option C is the correct one. I guess it's clear. Let's proceed. Okay, using the stock notation, represent the following compounds. Stock notation is nothing. You just have to write the oxidation state of that particular metal just in bracket, just beside it. So HAuCl4, when it comes, let's calculate HAuCl4. So for this case, x plus 1 plus 4 into minus 1 equals to 0, right? From here x it will get as 3, right? So I can write HAu3Cl4. That's it. Okay, Fe2O3, I guess you can understand iron is 3 oxidation state here, so you can write it simply Fe2O3 like that. Okay, I guess it's clear, the stock notation. Okay, this is something you have to balance in the redox acidic medium. Okay, very important. Any one of them you can get actually. This is the most common one, that's why I kept it. So yeah, let's proceed. So here you can see, first we will just separate the redox couple. Okay, so here you can see Fe2 plus will give you Fe3 plus. Okay, now here you can see another couple is Cr2O7 2 minus will give you Cr3 plus. So chromium, let's balance 2 chromium, and iron is okay. Now oxygen balance by adding water. So 7H2O I am adding this side, and here I have to balance the hydrogen. So 14H plus. Okay. Yes, everything is balanced. Now it's time to balance the charge. So while balancing the charge, please focus on the easy equation first. So here if I add 1 electron, it will be enough. Now for this case you can see here I am having plus 14 minus 2 and hence plus 12, right? And here I am having plus 6, right? 3 2s are 6. So here let's add 6 electron. Okay, now it's balanced, you can see. So now what I can do is further I have to multiply the equation in such a way so that the electron gets cancelled out. Okay, so let's say this is my equation number 1, this is my equation number 2. Equation 1 should be multiplied with 6. Okay, let's write all together. I'm writing. Okay, so 6 Fe2 plus Cr2O7 2 minus plus 14H plus, okay, that side 6 Fe3 plus 2 Cr3 plus 7H2O. That's it. This is your entire equation. Okay, I guess it's clear to you now. Okay, so while you are doing it in the board copy, please make sure you are doing it step by step, because each step can give you 1 mark. Okay, it is a 3 marker question. I guess it's clear to you. Let's proceed. Okay, in the following reaction 2Fe plus HCl giving FeCl2, what is the oxidation number? Okay, this is taken from the model question paper. Okay, so definitely oxidation state of FeCl2, it's going to be +2 here. What type of redox reaction? It's a basically 10th level question. It's a single displacement type of reaction. And which one is undergoing oxidation? Iron, there it is in 0 oxidation state in the reactant. It is coming to +2, means it is oxidation, right? Proceed. GOC. Okay, so now let's enter into the organic chemistry. Then 2 chapters are there, GOC, and then we are having, what is the chapter? Hydrocarbon. So these 2 chapter last. So please, whatever I have sorted already, whatever the list of questions I am giving to you in this session, please don't cut from here. Okay, this is the precise question, fixed question, you can say. Yes, expected that you can get 65 plus out of it. So please make sure you are going through all of them. Okay, let's proceed. Okay, acetaldehyde and ethanol. So acetaldehyde is something like, this is acetaldehyde, right? And ethanol is CH3 CH2OH. The formula is same, but the functional group is different. One case it is aldehyde, one case it is alcohol, right? So that's going to be metamerism, positional isomerism, tautomerism. Okay, that's going to be tautomerism, better to say. Okay, because if you are having this type of thing, and here I missed it, it is basically written as ethanol. Okay, that's the one thing I missed. Now let me explain. This is the ethanol. Okay, so this is basically a keto version. Okay, and this is basically an enol version. Okay, so keto-enol tautomerism is going on here. Okay, so you can say this is basically the tautomerism. Okay, it's not the functional group because I missed the term ethanol. I guess now you understood. It is basically the tautomerism. Clear? So yes, it's a lesson to you as well. Go through the question well. Okay. Next, in column chromatography, identify the mobile and stationary phase. So definitely the mobile phase is the liquid and the stationary phase is the solid, right? So this one, option B. Where do we get the PDF? Okay, so beta Malik Rehan, if you don't do the class, if you don't watch it up to the end, then I am not going to share the PDF. Okay, so one condition to get the PDF is please go through the class, learn it here, then you do by heart, then you do whatever you wish, but at first learn it. Okay, because your learning, it begins here itself, because whatever you learnt up to 10th grade, 11th level is completely different. It's way too difficult, my dear. So if you are literally planning for any kind of competitive examination, please start learning from here itself. Okay, so let's proceed. What is a functional isomerism? So I gave one example here. You can see one ether and alcohol. Okay, same formula but different functionality. Proceed. What is metamerism? So this is a very important question. Actually, it comes repeated here. I have seen it coming. Okay, so this type of isomerism is because of the uneven distribution of the hydrocarbon unit in two sides of the functional group. Okay, so you can see this is ethoxyethane, that is methoxypropane. Okay, this is metamerism. Proceed. What is the electromeric effect? So electromeric effect is basically complete transfer of pi electron when only in presence of an attacking reagent, otherwise no electromeric effect. Electromeric effect only it is observed in presence of some attacking reagent only. Okay, very important, inductive effect and electromeric effect difference. Okay, very important to go through. Proceed. Okay, this is a problem, this is a numerical problem. It is basically from the separation portion. So just let me go with it. Okay, the question is, in Carrier's method of estimation of halogen, 0.15 gram of an organic compound gives 0.12 gram of AgBr. Find out the percentage. So percentage bromine. For this case, you have to remember the formula. That's it. You can go ahead with the thing. So let me just write percentage bromine is basically equals to molecular weight of bromine divided by molecular weight of AgBr, okay, into weight of AgBr that you are getting, weight of AgBr divided by weight of the sample, organic sample, weight of sample into 100. That's it. Okay, now if I write it, so it's going to be how much? Molecular weight of bromine is 80. Fine, let me write them out at first. It is 188. Okay, here weight of AgBr 0.12 0.12 gram of AgBr divided by 0.15 into 100. I'm not further going ahead with the calculation. You can simply calculate it, and that will give you the percentage bromine. Okay, I guess it's clear. Yeah, let's proceed with the last chapter finally, that is the hydrocarbon. Okay, so here comes the first question. What is obtained in thermolysis of haloalkanes? That is free radical. Next, in the combustion reaction alkanes, if ethane is used, how many moles of oxygen or moles of oxygens are required? Okay, fine. So basically, whenever you will see it is ethane, any kind of alkane formula is CnH2n plus 2, right? Now, combustion reaction is going on. The number of moles of oxygen that is required, it is basically 3n plus 1 divided by 2. Always remember this. It's a trick. Okay. So, ethane, I am using ethane, right? Means C2H6, right? So, your number of oxygen is going to be 3 into 2 plus 1 divided by 2. So, 7 by 2 means 3.5. Okay, I guess it's clear. NEET aspirant, this type of question comes. Okay, proceed. Give the preparation of alcohols by Wood's method. You can see if you are having alkyl halide in presence of sodium in dry ether, it will give you the alkane. Next, soda lime, that is the decarboxylating reagent, NOH plus CaO. Boiling point of alkanes increase with increase in atomic mass. Why? Because the surface area increases, that increases the van der Waals force. Go ahead. This is very important thing actually. The mechanism of the chlorination of methane, very important question. Okay, so the 3 steps will carry 3 marks: initiation, propagation and termination. So initiation will be Cl2 will break down in the form of chlorine free radical, then that Cl will come, Cl dot chlorine free radical will come for the chain propagation. It will come to methane, it will break down methylene radical as well, it will get methyl radical, and you will end up with CH3Cl. Propagation, all the radical can combine, CH3Cl can combine, CH3 radical can combine, and Cl radical can combine. So 3 steps are important, 3 marker. Okay, next, aromatization of N-alkanes. Okay, one example you can see, one hexane you are having, in case of these reagents you are giving Al2O3 or V2O5, it will undergo aromatizing, first cyclization and then aromatization. Okay, so it will convert it to benzene ring. Next, what is cracking? Cracking is basically a big molecule you are having, it is getting converted to smaller units. Okay, see here you can see C6H14, you are giving heat, it can convert it to C6H12 plus H2 or C4H8 or C3H6. While writing this, please remember the number of carbon, number of hydrogen you are matching properly. Okay, it's very important. Proceed. One example is given, you can see C12H26 in platinum, palladium or nickel. If you just heat this, heptane and pentane and other products you will end up with. Okay. So let's proceed, explain the reaction of methane with steam. Methane with steam will give you the carbon monoxide. Okay, let's proceed. Let's proceed. Yes, my dear, you will definitely get 65 plus. These are more than enough questions are here. Okay, all type of numerical I have included here. Okay. So yes, definitely you will get. Next is write the Sawhorse projection of ethane. So this is the Sawhorse projection, both the eclipsed and the staggered you have to write. Next, Newman projection, both eclipsed and staggered. Next, discuss the preparation of alkenes from alkynes. Okay, first you can use the palladium and carbon in presence of carbon or charcoal, that is basically Lindlar's catalyst. So out of Lindlar's catalyst, what you will get? You will get only cis alkene, right? But if you need trans alkene, you can further proceed the reaction, means in the same alkyne, you can give sodium in ammonia and you will end up with a trans product. Okay, so when they are asking you to discuss about the preparation of alkenes from alkynes, discuss both how you should get cis and how you should get trans. Okay, let's proceed. Okay, explain the preparation of alkenes by the dehydrohalogenation. So dehydrohalogenation, what happens? The beta position, the hydrogen gets eliminated along with the halogen. Okay. What is the reagent? Alcoholic KOH. Alcoholic KOH in presence of heat, that will give you the alkene. Double bond will come. Next, Markovnikov's rule, very important, direct question comes out of it. What is the Markovnikov rule? The negative part of the hydrogen halide gets attached to the unsaturated carbon atom where there are lesser number of hydrogen. One example you can give out of it. Okay. Next, give two reactions to acidic nature of acetylene. Okay, fine. So acetylene, you can see this is the acetylene molecule and these hydrogens are highly acidic. Okay, so if you give any metal out of it, it will form the ethanide type of, sodium ethanide type of unit. Okay, so if you give even more, so both the hydrogen will be replaced with sodium, so disodium ethanide. Okay, let's go ahead. Mechanism of nitration of benzene, very, very important, three-step reaction. Okay, first step is the formation of the nucleophile, that is NO2+, that is the nitronium ion. That nitronium ion further is being attacked by the pi electron cloud of benzene and you will end up with the sigma complex or the carbocation. Then what happened? Getting back the aromaticity. Okay, so HSO4 minus, it takes the hydrogen and you will get back the nitrobenzene. Okay, gaining back the aromaticity. Okay, next, how does benzene react with excess Cl2 in presence of anhydrous AlCl3? Again, electrophilic substitution in benzene. So my dear, 3 electrophilic substitution you must know and you have to proceed the mechanism. Okay, because this 3, any one of them it may come, okay, in your examination, 3 marker question. Nitration, chlorination, and you can get the sulfonation as well. Okay, so here you can see, for this case it is not the chlorination, it's a different reaction. Okay, so benzene on reacting with Cl2, excess Cl2 if you give in presence of anhydrous AlCl3, dark condition if you keep, then all the hydrogen will be replaced with chlorine. Okay, hexachlorobenzene you will get. Next you can see this is a sulfonation reaction, that's what I was telling you about. Okay, first step is to get the nucleophile, that is to get the SO3. Okay, then this SO3 will be attacked in the next step by the pi electron cloud of benzene. Then what happened? Then this step is gaining back the aromaticity. So first what happens, the HSO4 minus will take this hydrogen and you will get the benzene sulfonate ion. So SO3 minus, further it will take one H from the H3O plus, you will get the sulfonic acid. So nitration is one of the most highly demanding question that usually it comes, then the sulfonation. So please go ahead with both of them. Okay, so mechanism is important. Okay, so complete the following reaction. For this particular case, wait just a minute. So this is a question you can get, it is taken from your model paper. So first case you can get alcohol, next aldehyde, next ketone. Okay, so these are the 3 consecutive different reagents are given and corresponding product alcohol, aldehyde and ketone you will get. Okay, so yes, that's it for today's session. I guess I covered entire zone of questions, though it is not the board paper this year it's given, but still these are the target zone of question. I guess you will get your common questions out of it. Yes, PDF also you will get. So I guess I could clarify your doubt. In case you get further doubt, please comment me below and don't forget to like, share and subscribe our channel. Thank you so much.